Right now, as you watch this screen, you are functionally blind to almost everything happening in your physical environment. Your nervous system acts as a massive receptor array, capturing 11 million pieces of sensory data every second. But as data travels to your conscious mind, it hits a strict biological limit. Only 40 individual bits actually make it through. The remaining millions of data points are instantly deleted. What you experience as reality is constructed entirely from that surviving 0.003%. Most people allow this massive data filtration to happen passively. They see everything but observe very little. High-performance minds learn to actively control this bottleneck. Selecting exactly which 40 bits survive the cut is the hidden cognitive architecture behind some of history's greatest intellectual discoveries. True observation is not a function of eyesight. It is a highly controlled neurological mechanism of data curation. Psychologists refer to this filtration process as selective attention. It operates much like a mental room, what the creator of Sherlock Holmes famously called the brain attic, a space where we categorize incoming data based on our specific interests. Your brain automatically pre-configures this space based on your daily routine, your profession, and your subconscious biases, deciding what material belongs inside and what stays out. If a botanist and a physicist look at the exact same falling apple, they capture completely different sets of data. The botanist isolates the ripeness and the health of the fruit. When Isaac Newton watched an apple fall, his pre-configured mental framework filtered out the agricultural details and isolated the mechanics of motion, pulling the raw visual data necessary to formulate the theory of gravity. Charles Darwin applied a similar structural framework. He filtered thousands of biological observations across different species into the specific data points required to map a theory of evolution. Operating at a genius level requires purposefully structuring your cognitive attic to catch high-value data points before they are deleted. Even when you intentionally capture the right 40 bits, that data immediately faces a second biological hurdle as it enters your short-term memory. This interface represents human working memory. Like a computer's RAM, it holds only about 7 distinct items simultaneously. If you try to memorize 15 random details, your brain instantly drops at least 8 due to overflow. This precise overflow failure is why many people mistakenly believe they have a poor memory. They capture the details initially, but the data quickly evaporates. Your neural networks are highly inefficient at holding on to isolated, abstract data points without an existing context to connect them to. To retain information, it must be moved to the brain's secondary storage system, the hippocampus. This region is designed for essentially unlimited, long-term retention. The engineering problem becomes clear. You need a mechanism to move critical data out of that fragile 7-slot working memory and encode it permanently into the hippocampus. Merely noticing a detail is useless if you forget it 10 seconds later. True observation requires a mechanical bypass for permanent retention. That bypass is a technique called spatial memory encoding, historically documented as the method of loci. The method of loci is a mnemonic strategy that relies on memorized spatial relationships to organize and recall information. You likely know it from fiction as the memory palace, the mental construct utilized by elite detectives to store and recall vast amounts of complex crime scene data. Arthur Conan Doyle embedded these very real, high-level cognitive techniques directly into his character's methodology. The technique works because human neurology evolved to prioritize three-dimensional spatial relationships and physical locations over raw logical facts. By anchoring abstract data points to specific physical locations within a familiar, imagined room, you force your brain to map information spatially rather than logically. Adding exaggerated narrative actions to those physical anchors increases the neural connections. Instead of memorizing an item on a list, you picture it performing an unusual action in a specific corner of your living room. This spatial narrative combination allows the brain to bypass the short-term memory bottleneck, transferring the information directly to the hippocampus. Elite observers actively architect their environment, translating flat data points into a permanent, navigable three-dimensional space inside their minds. Even with a structured brain attic and spatial memory techniques, you face one final obstacle: cognitive load. This is the thought cloud, the constant internal monologue and subconscious processing looping in your mind. It consumes your limited 40-bit processing bandwidth. Human infants operate as pure observers because they lack the language to form an internal voice. Without that mental chatter, their entire bandwidth is dedicated to absorbing the outside world. In adults, that internal voice acts as a firewall. The persistent mental dialogue causes your brain to drop external sensory data before it even reaches conscious awareness. This split-screen graphic demonstrates the McGurk effect, a perceptual error occurring when the brain receives conflicting visual and auditory information. When inputs conflict or internal processing is too loud, the brain generates a cognitive error, discarding real-world data to resolve the confusion. It is biologically impossible to observe external reality if your processing bandwidth is entirely occupied by your internal reality. To reclaim your processing bandwidth in real time, you must forcefully shut down the thought cloud. Box breathing functions as a rapid neurological intervention to clear the bandwidth. This geometric animation maps the physiological mechanism: a 4-second inhale, a 4-second hold, a 4-second exhale, and a final hold. This specific pattern increases oxygen delivery directly to the prefrontal cortex. That sudden shift in oxygen resets your autonomic nervous system, pulling your brain out of its internal loop and anchoring it into the physical present. Once the loop is broken, you initiate the secondary phase, sensory grounding. The 5-4-3-2-1 protocol manually reboots your sensory receptors. Hunt for 5 visual targets, 4 tactile sensations, and 3 distinct sounds. You force your neural pathways to recalibrate and begin accepting external data again. Managing cognitive load is a mechanical switch you flip to restore your data processing capability exactly when you need it. Mastering observation relies on 3 distinct actions: controlling your 40-bit sensory bottleneck, encoding critical data spatially to your hippocampus, and mitigating cognitive load. These protocols provide the biological framework for extreme intellectual clarity. The philosopher Jiddu Krishnamurti argued for a higher tier of cognitive function, defining true clarity as the act of observing the observer. Achieving this meta-awareness means actively tracking how your own mind filters and judges the world in real time, watching your own neural network parse reality. The physical environment will always be an overwhelming flood of noise. Engineering your mind to capture the correct 40 bits of reality allows you to navigate that flood with intent.